So this is a video on the second even and odd worksheet. Again, I want you to try these problems. I'm doing this video just in case you guys have questions. That way you can refer to this since I'm not there. So on this first one, remember, if you can reflect it across the y-axis and it's the same on both sides, it is going to be even. So this one is even. Now, B looks like it's going to be an odd, but you have to be careful. You have to reflect it here at the origin, okay, at the origin. So when I'm doing this, I'm looking at this line and this line because that's your X and Y axis. And what's going to happen when I do rotate this, you can see that this piece here is not going to match up with this over here. Okay, so it would if it was centered at the origin, but the asymptotes got moved. And so when I reflect this, you can see that this piece right here is going to be ending up coming down over here. Let me just flip it for us as a visual. Okay. So again, you see how this is coming here, but that's not how my original graph was. Okay. So it at first appears like it is going to be odd, but you have to pay attention to where the origin is. So this one's going to be neither. It's going to be neither. On letter C, again, this is a type of graph that generally would be odd if it was centered at the origin. Okay, that's the origin. So if I was to rotate it about the origin, you're going to see that this point here, which is at 0, -3, is going to end up now up here at 0, 3. So this, because it is not centered on at the origin on the X and Y axis, this is going to be another neither. On this one, obviously this is not going to be rotating, have symmetry about the y-axis. Otherwise we would have had the graph go like this and this, so that's not happening. If I was to rotate it here 180 degrees, what's going to happen is I'm actually going to end up with my V over here in quadrants 2 and 3 instead of 1 and 4. So let me rotate it. And you see how I'm in quadrants 2 and 3 when originally I was here in 1 and 4. So this is going to be neither. Okay. So let me write neither. Okay, this one here is going to be reflected across this. So this is going to be even. But if I rotate it 180 degrees, it's actually going to end up in the same spot. Okay, it's going to end up in the same spot. This point right here, for example, is going to end up over here. So this is actually going to be even and odd. It's going to be both. Now on letter F, this is definitely not going to be even. And again, when I'm looking at like this point here, which is going from 0 to 1, when I rotate it 180 degrees, it's going to be over here. Okay, from 0 to -1. So the orange, watch when I rotate it, is going to be at 0 to -1, like my blue currently is. Okay, so you can see it here. And that's not where I don't have graph there. I don't have graph there in the original one. Okay. My original one, I did not have any graph there. So this one is going to be neither. A lot of neithers on this one. On 2, the function is even, its graph is symmetric with respect to, this is just a review, to the y-axis. And this also means that if f of negative x, then it equals f of x. Basically that when whatever I get for a positive value, so for a positive one, I'm getting this, but also I'm getting the same height for a negative one. Okay. If a function is odd, its graph is symmetric with respect to the, we say, origin. And again, what we're really doing is 100 degrees rotation at the origin. So this means that whatever if I put in a negative x, I get the opposite of the value that I would have gotten for x. So, for example, none of these were odd except for this one. So for example, if I at +1, I got this value here, okay? At -1, I got the opposite of that value. You can see that that would be odd. Now it's also even because my +1 gave me this value and the -1 also gave me that same value. That makes it even. Getting the opposite when I put in a -1 of this makes it odd. Okay. So on these ones, I'm going to be putting in a -x and working these out. So on the back side here, for these, when we're trying to find these algebraically, we again are going to be putting in, whoops, hold on, a negative, okay, x. And so if I put in a negative x and I get out the same as f of x, that means it's even. If I put in a negative x and I get the opposite of f of x, that means it's odd. If neither happens, then it's neither. So on this first one, let me put in a negative x. So I'm going to have a -3 times a negative x minus 4. So a negative times a negative is a positive -4. So you see, I'm not getting exactly the same, so it's not going to be even. I'm also not getting the opposite because the opposite of this would have been 3x plus 4. So that means that this is going to be neither. On the next one, if I put in a negative x, I'm going to have a negative x squared minus, whoops, minus 3 times a negative x. So I'm going to get an x squared. A negative times a negative is a positive 3x. So first off, it's not going to be even because I did not get the same thing. Okay. It's also not going to be odd because the opposite of this would have been a negative x squared plus 3x. And that's not what I got. So this is also going to be neither. On number 6, so f of negative x is equal to a negative x to the 4th plus 2. So that's going to be an x to the 4th plus 2. And in this case, this and this are the same. So that is going to be even. On number 7, so I'm going to put in a negative x. So I'm going to have a negative x raised to the 6th, a negative x raised to the 4th, a negative x to the 3rd, minus a negative x. Now, anytime I have a negative raised to an even, like I do right here for this, I'm going to get a positive back. So that's going to give me, let me just write it down. I'll write it here. X to the 6th plus x to the 4th. So right now at this point, I've got the same. Now, when I do the opposite, I have a negative raised to an odd. That's going to be a negative x cubed, and a negative times a negative is a positive. So when you're looking at these, you want to be careful. They are not the same. The tops are the same, the bottoms are not. But what you want to remember is if I was to make this fraction opposite, I'm either going to make the numerator opposite or the denominator. So if I was to make the numerator opposite, that would be this, which is not what I have. Or if I was going to make the denominator opposite, I'm only going to make one of them opposite. That would be a negative x cubed plus x. That's what I got. So this is going to be odd. This is going to be odd because I end up with the opposite. Okay. Okay. On 8. So if I put a negative in here, 5 to the negative x to the 5th plus 3 times negative x over a negative x to the 3rd minus 2 times a negative x. Okay, so the top, I'm going to get a negative 5x to the 5th minus 3x. So far, it's the opposite of what I had in the original problem. Okay, over, and the bottom, I'm going to have a negative x to the 3rd plus 2x. So what happens is it doesn't look like it's the same, but if I make the top negative, opposite, I should say, and I make the bottom negative, which is a negative over a negative is a positive. So really this would be the same. I am going to end up getting a negative 5x to the 5th minus 3x, a negative 3x x to the 3rd, and a plus 2x. So this is actually even. This is actually going to be even. For this one here, if I put in a negative x, I'm going to have a negative x to the 4th plus 2 times a negative x squared minus 8. So I'm going to get an x to the 4th. I'm going to get a 2x squared, and I get a minus 8. I got the same thing. So this is going to be even. And that's the end of this video. Hopefully this helps.